Alright, so this LeetCode question is called merge sorted array. It says given two sorted integer arrays, nums1 and nums2, merge nums2 into nums1 as one sorted array. Note, the number of elements initialized in nums1 and nums2 are m and n respectively. You may assume that nums1 has enough space to hold additional elements from nums2. And we see nums1 has m equals 3 because it has 3 actual elements initialized, but it has a few placeholder indices available at the end. And then nums2 has n equals 3 because this also has 3 elements initialized. And the output is the sorted variant of those two, which is 1, 2, 2, 3, 5, 6. All right, so what would our final answer look like? So we'll take the first array, which is this, and it's going to end up looking like this. What's the smallest element of the two arrays? It's the number 1. Next smallest is the number 2. Next smallest is number 2 again. Then we have the number 3, then 5, then 6. So this array will end up looking like this. All right, so what we're going to end up doing is starting at the end of the first array, and we're going to compare the last initialized elements in each of the two arrays, and whichever one is bigger, we're going to put in the last element of the first array. So that'll look like this. So first we start off by comparing 6 and 3. Which one's bigger? 6, all right? So now this becomes 6. Now, since we've already looked at 6, we'll move this down 1. And then we'll move this to here, because this is the next one that's going to be replaced. So now we compare. Which one is bigger, 5 or 3? 5, so this becomes 5. And since we've looked at 5, we move this down to 2. And now this will be the next element that'll be replaced. So now we look again. Which one is bigger, 3 or 2? In this case, it's 3. So this becomes the number 3. And then we move this down 1 because we've already looked at that 3. All right, now which one's bigger, 2 or 2? They're the same, so this 3 now becomes the number 2. And then we move this here. But now notice that if you look at the second array, the arrow is pointing in front of the array. It's now less than the smallest index. So now we know we're done because there are no more elements to look at in the second array. So if you look to the left, the final answer is 1, 2, 2, 3, 5, 6, which is the sorted array that we're expecting. All right, let's get to the code. We're given a function called merge, which accepts 4 parameters. The first is nums1. This is the array that has enough space in it to hold all of the initialized variables, and it should be sorted at the end. Then we have m. This is the number of initialized variables in nums1. Then we have nums2, which is the second array, and then we have n, which is the number of initialized variables in nums2. All right, so the first thing we have to do is get a reference to the last initialized variable in each array. So we'll say let first equal m minus 1. So m right now is 3. And remember that arrays have a 0-based index, so that would be 0, 1, 2. It's there. And then we need one for the second array, so let second equals n minus 1. Same thing, it has 3 elements, so we need 0, 1, 2. Okay, now we have to iterate over both arrays backwards. To do that, we'll say for let I equals m plus n minus 1. So remember, m is 3 and n is 3, and we have to subtract 1 to get the actual index. And that would put us here. Remember, what we're going to do is start at this index, the furthest right index, and move left, adding progressively smaller elements from each array until the array is sorted. So next we do I is greater than or equal to 0, I minus minus. All right, now let's remember that if we're ever at this point in the second array, which is one element before the array, so the index is a negative, that means everything in the second array is now in the first, and we're done because that means everything is sorted correctly. So we'll say if second is less than 0, we just have to break. Now the next step is to compare first and second and see which one is bigger. So one sec, let me get rid of this. So now we're going to compare the element that first is pointing to, which is 3, to the element that second is pointing to, which is 6. If first is greater than second, then we have to replace this element with the element that first is pointing to. But that's not the case. In this case, second is less than or equal to first. So we'll have an else statement that says else nums1 I is equal to nums2 second. That would mean that nums1 I, which is this, is now equal to nums2 second. Second is pointing to 6. So now what we have to do is, since we already looked at second, we move it down 1. So we'll grab second and move it here. All right, so the next loop starts, which would put us here. We get to the if-else statements again. First one is if the number that first is pointing to is greater than the number that second is pointing to, which again, it is not. So we'll go into the else statement. So now we'll replace this with the number 5, because 3 is less than 5. And now, since we've looked at the number 5, we move this down here. So then the next loop starts, which puts us here. Again, it goes to the if statements. If nums1 first, which is 3, is greater than nums2 second. In this case, it is. So we're going to change this to 3. And that would look like this. Nums1 I equals nums1 first. And then what do we have to do? Since we've already looked at the number 3, we have to move that down 1. So first minus minus. And that would look like this. Okay, now the next loop starts. So this goes over here. Now we're back to the if statement. Is the number that first is pointing to greater than the number that second is pointing to? It is not, so now we're inside the else statement. So we do this again. We'll replace this with the number 2, which is what second is pointing to. Then remember, we have to decrement second by 1. Which puts us in front of the second array. Now we go to the next loop. Look at the first if statement. It says if second is less than 0. In our case, second is less than 0, Right now it's at the negative first index. And what does it say to do? At this point you break, so you end the loop. And then we're actually done. Now we look at the first array, and it's completely sorted, just as we expected. So let's run the code. Oops, small typo here. Run it again. Accepted. See how we did? All right, so our solution was faster than 86% of JavaScript online submissions. As usual, the code and written description are linked down below. See you next time.